Is Praveen and Akshay again, and we are going to introduce you to the lab 3 of E542 under Professor Yang Cho. So this lab is all about FTP. So FTP is generally a file transfer protocol which is used to transmit packets and file at the application layer. So this part of a project is basically to build a custom type of custom protocol which takes the good part of UDP as well as TCP. So what we have actually done here is we have built a layer over UDP. So the problem with general TCP is it's generally it has more delay when compared to UDP. UDP is much more faster than TCP. So in order to overcome this problem, we have built a custom protocol. So there are two scenarios which will be running here. The first scenario is will be here our systems are connected by a 1 Gbps link. So we are going to first transfer a 1 GB file over 1 Gbps network and see what the throughput is. And secondly, we also going to add the delay and the loss in the network and see how the network performs under those parameters. And lately we have also tested this over an 100 Mbps network. So if I could give you an overview of what our code actually looks like. So the code basically has two main parameters. So we have used multi-threading here. So the first part of the thread is generally taking packets from the file and transmitting and putting it over the SOC OPT buffer, and at the second thread is basically generally waiting for the NACs. So NACs are nothing but the signals which didn't go to the receiver which were expected to. So the receiver send a message saying that I didn't receive this, so the sender has to again retransmit those. So that part of it is only being done by a single thread, and the normal transmission of the packets are being done by the first thread. So this is generally an overview of what we have done in the code. Secondly, we also have to wait for the final signal to come so that we can terminate our program. So once we get a message or the final packet saying that all the packets have been reached at the sender side, a message has been sent saying that okay, it's been done. And once that message is received, you can see that we wait for that, and once that is done, we kind of end our program. So Akshay is going to take over and explain you what we did over the receiver.
So the receiver code also works similar to the sender code, where we open one UDP socket for receiving the file information and then open a raw socket after closing the UDP socket. The raw socket will basically do the file transfer process. So the receiver side also has a main thread which starts receiving the packets, and parallelly there's a child thread. We have named it as thread A, and that is used to receive the NAC acknowledgements, and it is used to send the lost packet information. So the child thread runs and gives the NAC information and receives these lost packets while the main thread is running. And as soon as the child thread says that all the NAC information and lost packets have been received, the main thread will then end, and so will the child thread, and then the process will complete, and we'll go to the end of the program. So yeah, these two run parallelly, the receiver and sender, and as soon as the whole file transfer is done, we end both the programs, and all the threads are then dead. Now Praveen will take you through the implementation of our lab.
Yeah, so I'm basically gonna transmit. Let me clear the previous stuff. So this is basically the receiver side, and this is basically the sender side. I'm just gonna clear whatever we were doing previously. So this is basically over zero lossless channel what we are doing initially. So and the delay also whatever we are setting here is gonna be 0 millisecond. So I'm just gonna set the delay to 0 millisecond, right? And I'm gonna at the sender side, let me see if I've removed all the junk code. Right. So everything looks nice. Let's run the server and let's see if our client, how does our client perform when it's sending a 1 GB file. So you can see there are 4 parameters. It's the port number, the file name, and the IP of the receiver. So let's transmit and see what throughput we generally get for 1 GB file over a 1 Gbps network. So we are waiting, it's checking for retransmission if there are any. Let's see. Generally it takes a little while for this to happen. Yeah, so as you can see, we got a throughput of 348 megabits per second over 1 Gbps network. And the other stats which I can overrun you through is the time it took for the transmission, that's about 23 seconds. The total number of bytes sent, which 1 Gbps, so you can just match that. And here you can see some other stats which are like how many packets were lost in the network and we retransmitted it. So that was exactly the same what we can see on the sender and the receiver side. So for the second part of it, we are basically gonna introduce loss and delay in the system. So let's introduce a loss of 20% and a delay of, yeah, so delay is gonna be around 200 millisecond, right? So right, so I'm just basically gonna run the server code. Hang on, just remove the file, previous file. This is gonna run the server and run the client. And this is basically gonna take a lot of time, so I'm just gonna pause the video and come back when the results are again present. So right, so I guess the transfer has already happened now. So you can see that the over the delay our throughput actually decreased a lot for a 1 Gbps network. It came around 91 megabits per second, and as you can see the time taken for this, and the total number of packets were transmitted again 1 GB of file. So the same procedure was again repeated for a 1 MB file for 100 GB 100 Mbps network over the delay and this. So those are actually recorded in a report. So as you can see that the time taken for this, Akshay will run you through all those.
Yeah, so we changed the link speed, downgraded it to 100 Mbps, and we observed the same results again as we did in 1 Gbps link. As you can see in the slide, we got a throughput of 61 Mbps uh, with the time taken for the transfer as 71 seconds for the 100 Mbps link, and we repeated the same like inserting the delay packet loss percent, and yeah, we basically got the same results as 1 Gbps. And what we observed is the throughput decreases and the time taken for the file transfer increases as we increase the delay and the loss rate. Thank you very much, and see you next time.